Alright, here's a really neat problem. In this example, take a look. They're giving us the graph of the derivative. This is interesting. They're giving us the derivative graph this time. In other words, they're giving us the slopes. Be careful, this is not the function, so how we solve it is going to be a little bit different. We still want to find out where the graph is increased. The graph of f of x, the function, is increasing, and where f has a relative maximum or minimum. So we've done this before. Given the graph of a derivative, we know if we're above the x-axis. Remember, this is our derivative graph. It's the slopes. So we know if we're above the x-axis that we have a positive derivative or slope. Below the x-axis, we know the slope is negative or a negative slope. And our critical numbers occur on the x-axis where the slope is 0, where the derivative is 0 here. So if I want to find out where this is increasing or decreasing, we again need to find our critical numbers. So we ask, where is the derivative 0, or d and e? In this case, we're just looking at where it's crossing the x-axis, because this is where my slope is 0. And that's going to give us negative 3, 1, and 4. So negative 3, 1, and 4. Doing the sign chart, just like we did before, I'm going to assume that there's arrows here. Doing our sign chart, negative 3, 1, and 4, and we want to know about our sign. We want to know how our derivative is affecting our function. And that's really what the sign chart does for us. How does the derivative affect my function? Now be very careful. We're only wanting the signs. Is this positive or negative? So if we look before negative 3 here, notice we're below the x-axis, and that tells me that my derivative is negative here. So I know before negative 3 the graph is going down, like a disco clown. Between negative 3 and 4, we're above the x-axis. Well, that's telling me that my derivative or my slope is positive. So it's going to be positive, or it's going to be going up, like a disco duck. Sorry, that should have been a 1, not a 4. There we go. And between 1 and 4, again, we're below the x-axis, and it's telling us again that we're negative. So it's going down. And after 4, again, we're above the x-axis, and that's telling me that my slope is positive, so we're going up. Remember, why do we choose these? Given the graph of the derivative, the slopes, remember, if you're below the x-axis, the slope is negative, and if you're above the x-axis, the slope is positive. And now we can answer our question, where is the function increasing? So we can say f of x is increasing on the following domains, negative 3 to 1 or 4 to infinity, and that is because the derivative is positive. F of x is decreasing on the domain negative infinity, where it's negative, to negative 3 or 1 to 4, and that is because the derivative is less than 0. A lot of writing. Not like stats class, though. And now if we look here, notice, if I do this in green, the function's going down. At negative 3, we turn around. At 1, we turn around again. And at 4, we turn around again. Oh my gosh, there it is. I didn't even see it. It is indeed the world-famous Wornow function. Crazy. This thing just pops up everywhere. But we notice we're going to have a relative minimum at negative 3 and a relative minimum at 4. So I'm going to go ahead and identify those. F of x has a relative minimum at x equals negative 3 and 4 because the derivative goes from negative to positive. Whoop, that's a weird looking negative. Don't make it look like a positive. They will not give you credit for that. And we can say f of x has a relative maximum at x equals 1. And that is because the derivative goes from positive to negative there. So it's just a lot of writing today. Oh, not so bad though. But the one thing we want to make sure you need the sign charts. Okay? All right, let's take a look at the next example here. This is kind of an interesting one right here. For this example, we're told that the derivative is less than 0, so that the slope is negative, that this is a negative slope on the domain negative infinity to negative 3, and that the slope is positive on the domain negative 3 to 2, and then it goes back to negative on the domain 2 to infinity, sorry about that. So if we notice, the function starts off negative, goes back up, and then goes back down, like so. So the first thing we're going to do is find our critical numbers. Well, the critical numbers are where the derivative is equal to 0 or d and e. Where is it changing? Where would the slope be 0 at? Well, I'm going from a negative to a positive, so the slope has to go from a negative to a positive somewhere between negative infinity and 2. Well, the critical number there occurs at negative 3. It's what they both have in common. So my first critical number is negative 3. My next critical number then, of course, would just be 2, where we go from positive to negative at x equals 2. Write your sign chart, f prime and f, negative 3 and 2, and they told me the signs were negative before negative 3, so we're going down. Between negative 3 and 2, where slope is positive, we're going up, and from 2 to infinity, it's negative, it's going down. And now let's ask the question. Ready? Then they say, if g of x equals 2 times f of x, what's the sign of g prime of negative 1? So we want the derivative here, so I've got to find the derivative. G prime of x would just be 2 times f prime of x. Plug in your negative 1. G prime of negative 1 becomes 2 times f prime of negative 1. I just want to know the sign. 2 times negative 1, well, where's negative 1 located? Negative 1 is between negative 3 and 2, and that's going to be positive. It's going to be greater than 0. So therefore, this is going to be positive. I only want the sign. That's positive there. Same thing here. I want to find g prime of negative 1, so I take the derivative. G prime of x becomes f prime of 3x minus 5, all tricky, times 3. Don't forget your chain rule. Plugging in the negative 1, we're going to get f prime. Plug in negative 1, we get negative 3 minus 5, which is a negative 8 times 3. Again, I'm only interested in the sign. So at negative 8, where's negative 8 located? Oh, negative 8 is way over here, off to the left of negative 3, and I already know that the sign there is negative. And so I know that, therefore, this is going to be negative, because a negative times a 3 is just a negative right there. There's our answer. All right. So now let's talk about some real fun stuff. Let's say that our function now represents a particle in motion. So this is now some sort of particle that we have. And we are moving along a line. And the first question says, find the velocity of the function. That's not too hard to do. We know from physics that the derivative of position is velocity. We talked about that earlier. This is from earlier, okay? Earlier than this year. So if I take the derivative, I get 2t minus 7. There it is. So there's my velocity equation. And if I can use this now, let's say I wanted to find the velocity at t equals 3. I can just plug it in now. V of 3 would be 2 times 3 minus 7, or negative 1. That negative 1 tells us we are moving backwards. That's what a negative means for it. Velocity is just always going to give us some sort of direction. And that's what the next question is kind of telling us. Identify the times which the particle is moving in a positive direction. What they're telling us here is that the velocity, or the derivative of position, has to be greater than 0. So we have to use our derivative. This is our sign test. This is our first derivative sign test. So this is our first derivative test. So if I take my first derivative, find your critical numbers, we want to know where does the velocity equal 0. So I can do that. 2t minus 7 equals 0. I can get t equals 7 over 2. Write out your sign chart. Starting at 0, they're telling us start at 0. They're telling us to do that. Here's 7/2. My velocity, and how does it make my position feel? Okay? How does it make my position look? Right there. So I pick in something. So I'm pick something between 0 and 7/2. I'm going to let t equal 1. That's really easy. Plug it into your velocity equation, 2t minus 7, and you're going to get a negative. So that's telling us we're moving backwards. Between 0 and 7/2, we're moving backwards. Velocity gives me direction, and that's what this does. This is a direction finder. It's going to give me a number, but this also gives me direction. We're moving in the negative direction in this case. If I pick something bigger than this, like t equals 10, well, that's going to be positive. It's going up. It's moving in the positive direction, or we're moving forward. So we can say that the particle is moving forward on the domain 7/2 to infinity, and that is because the velocity is positive, and that's how we're going to write it. Piece of cake to do. Identify the time interval at which the particle is moving in the negative direction. Well, we already have that in our sign chart, so we can say the particle is moving in the negative direction, is moving in a negative direction. And up here, I said moving forward in the positive. Here, I'm just going to use the words that they're using. In the negative direction on the domains 0 to 7/2, and that is because in this situation, the velocity is less than 0. And the next one says, when does the particle change direction? And again, I have my sign chart. Ta-da! When do we change direction? At t equals 7/2. And we can say that the particle changes direction at t equals 7/2 seconds, units, whatever, because this is where the velocity, and we're going to say it this way, changes signs. By changing signs, let me write that a little bit nicer here. By changing signs, we are saying we're changing direction. Change your signs, change your direction. I hope you guys enjoyed the video, and I will see you all later. Bye-bye.